So before we talk about how you could virtualize the CPU and all of that, I thought it would be instructive to actually remind ourselves about instruction set architectures and how they are composed of the system and user ISAs. So the instruction set architecture defines the visible state of the hardware to the programmer. It primarily consists of the registers and the memory. The instructions that operate on this state would actually define how you interface with the hardware. So the user ISA in particular actually is used for things like loading and storing from and to memory, add instructions, what have you. The system ISA is actually used primarily for system resource management, and typically we also call this as the user ISA and the privileged ISA, or the unprivileged ISA and the privileged ISA, and I'll be using these terms interchangeably in today's talk. The user ISA itself, as I said, consists mainly of the user virtual memory, and I'll talk a little more about virtual address spaces later on. It consists of the general purpose register set and some special purpose registers like the program counter, the condition codes, maybe some other registers like the page table base and so on. Sorry, the page table base I'll talk about in the next slide. And then the floating point registers themselves, which are used for other kinds of computation. So the system ISA consists of the privilege registers, which are also called control registers, one of which is the page table base, and you can have other kinds of privileged registers like the current mode you're executing in and so on. It also has trap and interrupt handlers, handling code, and then the system clock, the memory management unit configuration, I/O device accesses, and so on and so forth. And I just wanted to remind you that there are different organizations possible for the user and system ISA. Some architectures actually just have one privilege level for system, one privilege level for user. An example of this would be ARM. Other architectures like the x86 actually have 3 or 4 rings, for example. Some of those are actually more privileged than the others. So it basically starts off with the least privilege and then goes on to the ultimate kernel, which actually occupies the most privileged level.